Almost a week ago now, Cursor added a new stealth model called Cheetah. A lot of people online have been saying that it's actually Gemini 3, but if you ask me, there is no way that it's true. I'm super excited to delve into the details, but first, an ad break. Quick question, have you ever felt like ChatGPT is either too slow and that sometimes it doesn't even work? Now for me personally, that is certainly the case, and I have seen this with many others, which is the exact reason I built Shiori, which is a ChatGPT alternative that looks better, is half the price, has more models, and better tools. You can ask it something like, what do I have to work out on Monday according to my workout routine in Notion? Then it will search for the specific page, it will retrieve its contents, and it will show you what you have to work out. Now for me, I had shoulders and abs. Obviously, it also has access to tools such as web search, which should be default. It has access to a code tool, and by far one of the coolest features is that you can summarize YouTube videos. Let's give it a shot. Let me paste this in, press enter, and I can say summarize this video. And now it will give you a complete summary of the topic discussed in the YouTube video. You can obviously also attach files, you can attach websites or articles, and most importantly, you have access to a bunch of models. And lastly, the pricing. This is priced at an incredibly competitive level, especially compared to ChatGPT or Claude. You can see the Plus plan is only $10 a month, you get all the tools, and you can personalize it. Now personally, I am on the Plus plan, and if you have a look at my profile, you can see that I haven't used that much yet, and it's already the 10th of October. And the Pro plan is just for power users who need a lot of credits, which isn't most people, to be honest. Now here you can also see all the tools that Shiori has access to: web search, web visit, image generation, video generation, file analysis, YouTube and Notion integration, text-to-speech using 11 Labs, and lastly, code execution. Now, something that's also very cool, you can build small little web apps using HTML and JavaScript. For example, here I built this gravity simulation web app, add a particle, clear all, and you can obviously see the code associated with the project. Sorry for the interruption, and let us get back to the video. Now, I tested the model using 3 benchmarks. First, a black hole benchmark, which I wrote myself, the hexagon balls, and the utilities dashboard. Now, I'll go through them step by step and show you how the model performed. Now, one thing that's really weird before we start with the benchmarks, this model isn't free. So if you actually have a look here, it says stealth model from an undisclosed provider, available for a limited time only. During the stealth period, the cost is $1.25 per million input tokens and $10 by million output tokens. And believe it or not, this is actually really strange. This is the first time we've seen a stealth model that costs money. And this could potentially give us a hint as to which lab created this model. So I will upload all these benchmarks to GitHub so you can take a look at them yourself. But first of all is the black hole visualization. Now, there's a lot of big words here, but the essential part of this that you need to understand is we're basically testing its capabilities with physics, and specifically particle physics. And the Schwarzschild metric is really just a formula that you can use to calculate the gravitational mass around the black hole, which is first of all not rotating and is symmetric. Now, later on, we'll also be doing this with the Kerr metric, which is for rotating black holes, but you can see this all in the code. So for example, here I have the Kerr metric file, and here I have the Schwarzschild.py file. And the way that you run this Python file is to just go into your terminal, type source.ven activate, or yeah, first of all, we have to go into the black hole directory. We can then activate the virtual environment, and then we can run uv run main.py. And you see this takes quite a time to start up, but then we get this. Now you might think that it initially failed, but it hasn't even started yet. It's still rendering, which is understandable since it's a lot of physics that it has to do. And it's not just the black hole that has to be rendered in itself. We're also rendering a lot of stars so we can actually see the gravitational lensing around the black hole. And this is basically how gravitational lensing looks like in real life. So as you can see, we can't actually see the black hole. This is just a star. Now this is from behind the black hole actually. Now, as you may or may not know, the reason black holes are black holes is because their gravity is so strong that even the speed of light cannot escape the grip of the gravitational force of a black hole. Sorry for the quick physics lesson, but I think it was just necessary to understand what we're trying to calculate here. And again, what we're trying to calculate is the gravitational mass on the black hole, which is the reason you can see all these stars around it. And here is the first problem. Although I really would have liked to test this out, it just failed to write good code. I mean, my computer is very powerful. I have an M1 Ultra Max Studio with 64 gigabytes of RAM, and it should be able to write through these calculations. And I know that because I tried the same exact prompt with Claude Sonnet 4.5 and it worked wonderfully. Well, really, I can show you real quick how it turned out with Claude Sonnet 4.5. So here we can see the gravitational lensing, which looked like this. Now this is not really accurate since The code itself was also not perfect, but at least it rendered something. Now the benchmark I used to generate these tests is called Grav, and I'll actually link in the description if you want to try it out for yourself with an LLM. And I think it's fair to say that it has failed horribly at the Grav bench. So we'll give it 0 out of 10 points. Now on to the next benchmark, which is the hexagon balls benchmark. And if you're not familiar, in the end, it should look something like this. The balls cannot go outside of the hexagon, they're supposed to kind of go with the flow. Now you might think this is very easy to implement, but if you actually have a look, it didn't perform really well. And I was honestly really surprised to see this. I mean, we can reset as many times as we want, and it just really doesn't work. This is supposed to be one of the simplest tests, and the fact that in 2025, specifically October, we still have an LLM that cannot do this is mind-blowing to me. And this is really what I meant when I said this cannot be a Gemini model, and especially not Gemini 3. Gemini 2.5 Pro would completely crush this benchmark. And yet, if a higher model performed worse than the one before it, that model would obviously not be from the same lab. Now, I have been hating on this model, but let me show you a really cool thing. So I want to show you the speed of the model. And we can do this by just saying implement and then copying the prompt I used for the hexagon spinning ball. Then obviously you select the cheetah model and look how fast it implements it. As you can see, it's chewing right through the tool calls, which is really, really cool. And yeah, I forgot to tell it, make a new one in a new directory called v2. Well, wrote v12 now, but whatever. Yes, run. Here we can see another one of the reasons why I moved off of cursor, mostly because it's just very slow with the tool calls. Okay, so now it's writing the code. And it wrote 300 lines of code really quickly, which is faster, a lot faster than you would expect from most models. So let's have a look here. Okay, it's done. Keep all. Let's hop into our terminal. Let's go into v12. Let's do uv run hexagon balls. And it still fails. This is ridiculous, honestly. But whatever, we already knew that it didn't work. The main point here is that it's really fast, which leads me to believe that this is a diffusion model and not a traditional transformer. Let's go into Shiori and ask what the difference is between a LLM and a transformer using GPT-5 Nano. Let's also tell it, do it short. I am making a video. Core idea. Transformers generate text token by token using self-attention. Diffusion models generate text by gradually denoising noise over many steps. Now, what even is a diffusion model and what's the difference between a normal model, which is a token-based model? Now, I'm not going to delve very deep into this topic, but I'm just going to give you a quick outline of what the main difference is while generating output from the two types. So in the diffusion model, you have something called a noise. And the noise can really be data which is incorrect. The way we generate text in a diffusion model is to just go through steps that continuously remove the noise. And this process we call denoising. And then we get a new noise which has less noise in it than the first one. And basically we do this over and over again until we have something which doesn't have any noise in it, or at least very, very little. And this we call the output text. Now this process is much faster since you don't have to use math to predict the next token, such as in normal models, but this process has one drawback, that the quality of the output is not very high. Now let me give you just a quick example. The noise could look something like this, and the new noise could look something like this. Just an example, and the output text would look like this. And as you can see in each step here, removing noise leads to a coherent output. In our case, this is hello. And why am I saying this again? It's because I think that Cheetah may be a diffusion model just because of how fast it is. I've honestly never seen an LLM this fast. Now let's get to the last benchmark, which is the Japan-themed utilities dashboard. A beautiful, minimal utilities dashboard for macOS with Japan-inspired design elements. This dashboard provides easy access to common system controls and information through a clean and modern interface. Now what I wanted to do here is exactly this, only for macOS using AppleScript. With this, I wanted to test its knowledge of hardware-specific code. And if you take a look at it, it generated quite a bit of code, but not as much as I would have expected it to. Now, this also includes the React application since I told it to make one. And I don't like this right here. A lot of use states This looks fine to me. This looks also fine. Good that it catched this one. But yeah, generally fine code, nothing special. Now, one thing that we haven't seen from this model yet is the UI it generates. Now let's go to the README and see how we can run this. Okay, we can just do npm start and python app.py. Let's do this. Source.venv bin activate uv run app.py, and we can go to the new one, say cd utilities dashboard and on start, which should open a URL for us. Something is okay. Let's use another port. No, sorry. Yes. And it looks like utter garbage. I mean, what even is this? Now, I may have congested the input by adding this part to the prompt right here, Japan themed. This is not Japan themed. This is nothing themed. This is just Claude themed. But I still don't think it's Anthropic that made this model, just because they would have probably just put it as a free option and not charge for it inside of Cursor. But yeah, you get a couple of system actions. You can see the name of my computer, the system version, the CPU usage, memory usage. You can turn up and down the volume. Slider doesn't work very well, obviously. Not at all, apparently. The brightness level doesn't work. I mean, this slider at least adjusted the volume. This straight up just doesn't work. I would love to test this, but I'm recording right now, so I'll just let you know in the comments if this worked. Wi-Fi information, it can't get any of this. Now, execution the command exited with a non-zero status. Not an interface. Okay, so I don't think these are permission errors. This is just errors in how the model did things. You can see the disk usage, and yeah, very useless dashboard, honestly. I would have expected a bit more, but it's whatever. It obviously didn't pass this one either. Well, it was able to generate code, as we can see, but it just doesn't work, first of all. Secondly, it looks utterly garbage. But this right here, these shadows, I haven't really seen from another LLM. So this might be an interesting catch. But yeah, as we can see, this model is not really the best at either UI, logic, or anything else it does except for its speed. But I think in agent workflows specifically, where speed matters and quality not so much most of the time, this could be huge. But I don't really think you should use this model for code. It isn't really smart, even for simple things such as the hexagon ball. Now, fixing small linting or typing errors could potentially work with this model, but you would have to use something like the Command K interface instead of the agent. Another thing is it's really good at tool calling. It can do parallel tool calls, as we saw earlier, and the speed itself is really the biggest selling point for this model. I'm really excited to find out who this model was made by, and let me tell you my prediction. I think it was done by Grok. They have a history with producing shitty models that are at least fast. But even for them, the level of intelligence here seems abnormally low. So even if you held a gun to my head, I wouldn't 100% call it a Grok model. I think it's just one of the higher contenders up there. So yeah, overall rating, maybe 4 out of 10. Don't use this model for coding. Please, just don't. If you want to use it for anything else in workflows or stuff, go ahead and use it, but you can't do that yet since it's only available in Cursor, as far as we know. With that said, I'll see you next time.